Hello everyone! In this video we are going to compile the steps to process the marginality indicator layers. The objective of this exercise is to show you how to prepare the soft indicator layer to obtain a raster for each indicator with three values corresponding to three marginality range: high, low, and potential unsuitable low. To do this, we will first reclassify the raster according to the threshold and then multiply it by the corresponding weight. As we don't have time to review all the 17 indicators, we will only use 4 that I have considered important and are the ones we will use in the exercise in the next section. We can imagine that these indicators are the most important for us to carry out a reforestation or afforestation. These indicators are depth available to rot in centimeters, soil texture, soil organic matter, and slope in percent. For the first three, we will obtain free for the European soil dataset, whose acronym is ESDSC. Soil organic matter and texture will be worked at topsoil and subsoil level. The texture will be worked following the formula we saw in the previous presentation, and for which we will need the clay and silt layers. We will also use the slope derived from the 25 method UDEM from the Copernicus. In addition, I have left you a row with the study area in vector format to be able to do the exercise. Otherwise, the processing will be too slow for the whole of Europe. All the files are in a zip file in the material of the section, and you can also download them from the links of the presentation. On the other hand, we are going to work with Qgis software because it is free. If anyone don't know this program, can download it and discover its full potential of the Qgis project website. You can also use any other geographic information software. We will start with the creation of a project in Qgis, and in my case, it is the version 3.6.0 with grass 7.6.0 because it is the one in which the model designer works best for me. You can try other version, of course. You go to project. For the first step, select Save As, and we decide first of all the path that we are going to save our project, and we decide a name. In this case, for example, we can put section 3 to solve exercise, and we press Save. Here are the threshold and weight we will use to process the 4 layers. These values are the same values we use in the MaiL project. The depth available to rods, soil organic matter, and slope layers will be processed manually, and the soil texture layer will be processed with the processing modeler. The first layer we are going to edit is soil depth layer. So, to load the layer, we have two options. We can load it directly to the layer panels or to the map display, or we can go to Layer, add raster layer, because in this case we want to add a raster layer. In this window, we need to find our path. In this case, is deep available to rods and deep original, and here we have our raster, and press Add. We are going to do the same with the row, but in this case we choose the first tool, that is Add Vector Layer, and we want to find the row, and here you have, and press Add, close. This procedure will be the same to load all the layers for this exercise, and as you can see in the beginning we have the raster layer of soil or soil depth available to rot for whole Europe, with values between 0 and 150 centimeters, and a ROI vector layer that delimits our study area in Spain. For a better view of the layer, I am going to change the symbology, and for the file color I am going to keep out. I'm going to change this one to red. So in this way we can see the raster layer below the vector. The first step is to reclassify the raster, and to do this we will look for the word reclassify in the processing toolbox. If you don't have open, you can do the same like me, and here you can write reclassify. We are going to work with the reclassify by table. The first thing that this tool asks for is the input raster layer that we want to reclassify. In our case, we will select the only loaded raster layer. Once the layer is loaded, it automatically shows the number of bands. Next, we will display the reclassification table that we will create based on the threshold defined in the last presentation. You also have these values in this presentation and in txt file named reclass. If we do a double click on the three dots icon, we can prepare a table. In this case we need 5 rows, so we will click on add row 5 times and complete with the established threshold. It means from 0 to 0.009, the value is equal to 0 to represent the bedrock soil. From 0 to 0.1 to 33.3 centimeters will be considered low depth, for example, a very unfavorable soil, and we will give it a value of 1. The first one is 33.3001 to 66.7 centimeters, and we will give a value of 5 representing areas with low productivity. And from 66.7001 to 100 centimeters, we will give a value of 10, because we will consider then the best zones. More than 100 is going to be 0, it's going to be considered like 0, like in the MaiL project. When we finish the table, we press OK, and we can see that we change these values. The rest of the parameters, such output, no data value, or range, boundaries, or output data type, we can keep as default. We only have to save the result, which will be an intermediate raster layer, and we need to save in a folder. To me, this is the folder, and this is the name that I want to give. When we choose the name, we press Run. When the process is finished, we can change the layer symbology to see the results. To do it, we can press right-click on the reclassified raster layer and select Properties. In this window, it displays a series of properties where we select symbology, and we can, in the fifth folder, we have also provided a style for the reclassified layer, so you can load that directly. To do it, you can go to the button, to press Style, load the style, and choose Style Reclassify Indicators. Open, Apply, and OK. And you can see the reclassified raster. As we have already reclassified the raster, we will now multiply it by its corresponding weight, and in this case is 0.17. To do it, we go to the processing toolbox another time and we search for Raster Calculator. The first thing this tool asks us is the expression we want to make. We will multiply the reclassify raster by 0.17. About the other parameters, we only change the cell size 10 meters. The output extent is like the extent of the ROI, and the output projection, that is LAEA. Finally, we will give it a name and an output path. Here I am going to change this. I am going to put 2 and add weight. Save and run. When the process is finished, we are going to press close and we are going to change the symbology that, as we have done before. In this case, you press properties, style, load style, and we choose the deep indicators. Apply and OK. Finally, we have a raster with four classes that represent the defined range and that we will be used to calculate the marginality of the territory. These values are 0 for non-marginal, 0.17 for potential unsuitable land, 0.85 to low potential land, and 1.7 for high potential land. Well, for the soil organic matter layer, we will do a similar procedure with two differences. The first one is that we will have to repeat the process to the topsoil and subsoil. And the second is that we have divided the range of values in two. So we will only have high potential land with value of 10 and low potential with value of 5. In this case, and to make the video shorter, these steps will be shown in fast motion, but as it is a video, you can stop it as many times as you need. So at this point we have two layers, and the next one is the slope. Here you have the threshold and the weight. To obtain that slope, we will use the UDEM for Copernicus, and in this case the layer we have provided you is a raster only for the ROI and not for whole Europe because it has very high weight. Okay, first of all we load the layer. But at this point, you know, at raster layer, and in this case, in the folder number 3 slope, you have the UDEM raster. We observe that they had values between -10 to 2025 meters. If we modify the style, we can understand these values. You look in this part of the raster and we will notice that the negative values correspond to land near the sea, such as the rice fields near the Albufera of Valencia. Consequently, these negative values are not errors because correspond to lands areas that are below the sea level. The second thing we will do with this layer is to calculate the slope in degrees, and we will do it using the GDAL algorithm slope. We go to the processing toolbox and we type slope. The first thing that this tool asks is the input layer, and we choose the EUDEM ROI. We can leave all the default parameters, and if you want to investigate more, I recommend you to check the help. However, we don't want to mark the computed ages and we don't want to use this other formula. We only want to calculate the slope expressed as percentage. Then we go to save our raster to a file. In this case, I am going to put this name, one EUDEM slope. Save and run. In a few seconds, the tool is going to stop and then we close this window. If we look at the resulting raster values, we can see that the maximum is 477%, which is in degrees corresponds to 78.2 degrees. The third step will be to reclassify the raster as we have done before. To do it, we go to the processing toolbox and we put reclassify by table. The first thing is to select the raster layer, slope, and the second is to draw our table. In this case, we have the first is 0 to 40, and this is the value 10 because this is the best zones and the best lands and with the high potential. The second one is 40.0001 to 65 and the value is 5 that represent the low potential. The third one is 65.0001 to 90, that is value is 1 and represent unsuitable marginal lands, and a slope above 90% 0.001 to the maximum is going to be 0. We press OK and we save our file in our folder then processing with the name 2, and I am going to add reclass. Save and run. Okay, then we have here our new raster, and the next step is to multiply with the value with the weight. In this case, we go to find the Raster Calculator tool and we choose our raster and multiply by 0.70. Remember that you have to change the cell size, the output stance, like this ROI, and the output projection, and we are going to save this raster with the name weight. We press save and run. Then we obtain a layer that we can change the symbology as we have done before, and in this case we can copy the style from the deep available to rods layer because it has the same range to this. Here we can see the different marginality types with the different weight. At the moment, we have already processed 3 soft indicators: slope, deep available to rods, and soil organic matter. In the next video, we will work with the texture indicator in the processing modeler of Qgis. I hope you like the exercise, and if you have any question, please write to me at the email that appears in the presentation. See you in the next video.